Hello and welcome back to my workshop. My name is Robert. I haven't posted a video for the past few weeks, but then life's been somewhat busy. Not only have we had our annual holiday, but unfortunately a few weeks ago I lost my father, so my time has been employed elsewhere. Anyway, for the past few days I've found some time to get back in the workshop and I'm carrying on with my projects. In this video, which is going to be the first part of a multi-part series, I'm going to be machining a radius dresser. Now this will be a very simple version of a radius dresser rather than the all singing all dancing ones that you can buy. But these things are very expensive and for my needs I will probably only use this once. I don't want to spend a fortune. For those of you not familiar with a radius dresser, this is a tool that's used to dress a radius on a grinding wheel on the surface grinder so that you can make hemispherical grooves, for example, which is what I need it for. So I hope you enjoy it. Let's get on with it. This is my initial design for the radius dresser that I'm going to be making in this video. It's designed in a 3D design package called Design Spark, which is a freebie download off the web, which I've been using for a while, and I find it meets the requirements that I have. The design itself is in three main parts. There's this frame or body, a spindle at the back here, and the diamond tip dresser. The spindle at the back here goes into a collet in a spindexer, and the spindexer then provides the means to rotate this about an axis. The diamond tip dresser in the end here it's one I've already bought. It's a 1/2 inch diameter and it has a 1/2 carat diamond in the top. The height of the diamond away from the axis here determines the radius that this will grind. Now I plan to set this radius with, I have a bore in this spindle here in which I can insert a rod of known diameter. I can use that rod to determine the spacing between this face here and the center line of the rotation. I can place a micrometer on this surface here and use that to determine the height of the diamond above this surface, and therefore by difference the difference between the center line and the tip of the diamond, which will give me the radius that this will grind. The whole thing is held together with two 1/4-20 grub screws, one in here to secure the diamond at the right height and one in here to make sure that the spindle stays in the same position in the body. So for material to make the body of the radius dresser, I've got a choice of these two pieces of material here. The smaller one is ideally sized widthwise to just take a small chunk off the end, but this is tool steel and it seems a hell of a waste to use a piece of tool steel for something that could be made out of cast iron. This is a piece of flame cut plate. It's very large, it's 30 inches long. It's only 4 inches wide, so I'll have to cut about 5 inch length of it. But since I'm probably never going to make anything that requires a huge chunk of material like this, which is very heavy, 1.5 inches thick, I think I'll go with this one. It's been flame cut, so it's probably going to have a bit of a hard skin on it. So I might just stick it in the shaper to rough the surface off. About 4.5 inches. Let's cut it off. It's labouring somewhat, so I'm going to set it out vertically instead. Well, that was fun. Of course, now I need to knock the edges off. It'd be nice if I had access to my vise, but workshop's a little bit busy at the moment. So it's over to the board that I use to protect the bed of my lathe, and just get these edges off. I've given myself 3/16, something like that, excess material. I'm going to cut here and here. I'm first going to have to drill a hole here. Should do. That's a 1/4 inch from one line and a 1/4 inch from the other. I'm going to stick a 10mm through there, and eventually maybe it'll have a 1/4 inch radius. So here we go again, saw cut part 2. I'm giving myself quite a big margin. There's going to be quite a lot of material to remove, but as I said, I'll probably use the shaper to do that. It's not perfectly square there. Let's try and get it square to the bottom edge. out. Something doesn't sound too happy. The motor's extremely hot, that's been working overtime. I'll finish this off with a handsaw, with a hacksaw. It's only a couple of minutes worth of sawing to go. That is warm. So after nearly an hour's bandsawing, this is where we've got to. This length along here is nearly the right length. The height here, this will be 1.5 inches, so there's 1.25 inches to come off of that. That's probably more bandsawing, but I'll give it a chance to cool down first. So our plan from here is to cut this piece off, giving plenty of clearance. Then I'm going to use this sawn face here as an initial reference. I'm going to treat this thing roughly like a piece of casting, because there's nothing that's true on any of the faces. So I'm going to use this as an initial reference, because this will be the most crucial face once the thing is finished. I'll use this as a reference to get the underneath flat. At the moment it's a flame cut surface and it's not true. Then I'll clean up this, then we'll clean up these other faces and get them true 90 degrees to these two faces. I'm going to take the width down slightly. This is 1.5 inches wide. The design I had was 1 inch wide, but I'm not sure I'm going to take it down that much. I might knock 1/4 inch off it. So I'll give the bandsaw lunchtime to cool down and then chop the top off, and off we go again. Right, we're ready to go. So I've got this set up in the vise in this orientation. I have to use the vise this way because the two ears on it are too wide to fit in these slots. But this will work out fine. I want to have it in this orientation and cut towards this block here, because side to side the base is not true. So if I rotate it 180 degrees and sit it on a parallel, it will sit cocked off to one side. So this way I'm using the original flame cut of the base as the reference for now. I'm going to cut this surface until this is clean, and then we're going to flip it over and machine the side that's being used as a reference at the moment. This first cut is 10 pound deep. The finish is very horrible. I went for a fairly light first cut because at some point it's going to get quite deep. Bearing in mind the surface is not actually flat yet. Let's get it out and deburr it. That's the finish we got on there. That's not bad. This surface, this is going to be a temporary finish anyway, because I'll grind this surface until it's perfectly smooth, flat. But I do need this flame cut surface to be flat as well, so that I have something to put down on the mag chuck. This might work. Just wasn't happy with the way it was gripping, so I'll put those so they end at the end of the base there. That's got much more of a positive feel to it. That's better. Give that a light nip. Yes. Feels not bad. That's it. Both parallels are now tight. That should be just sitting on the parallels on that machine face. So time to rip that surface off. Now with the stroke set, feed it to its furthest forward position. That's the ram right at its furthest extent. That should do. Just. Right. All set up, ready to go. Sounds hard. Could be that I need to go back to the other edge, touch it off on this side, and then make sure I get underneath this hard skin before we even start. Okay, so I'm going to give it 15 thou. There's at least 20 thou difference from one side to the other here. That's not too bad. And for those of you who notice that the clapper is straight up and down, hands up. Yep, I didn't move it one way or the other. I should have done. But it's just come out okay anyway. One of my late grandfather's spanners fits that perfectly. So that will move away from the cut. And the extra bit of leading edge on there won't hurt anything at all. So now we go back to the beginning. smoke. So this is the shear tool that I'll be using. Nice big radius on it, an angle, and we shall try and push the chip across towards the material that's not been cut yet. So I shall set that up in there. This is the way I usually do it. So I'm putting it down against the surface that I'm about to cut, so I'm already at about 0. I'm going to drop the speed when we finally get there. The rounded end should leave, shouldn't leave quite the same sort of ploughed finish, but we shall see. The video's not showing it, but my impression is that the finish is worse. Let's pause it and try and have a good look at it. Or maybe not. It's got more tear marks in it, but the finish is actually very smooth to the touch. It doesn't have that same ploughed finish. I'm going to up the speed and see whether that makes a difference. Whilst we're doing this, whilst we're playing. I wouldn't have said the speed makes a big difference. It's definitely smoother. It's definitely smoother.